Hello, everyone. Welcome to the second session of today and also the second session of the Connect University Autumn School on Secure and Sustainable Digital Infrastructures. I'm Alex, the project lead on Connect University, and I'll be your host of the entire week. But today I'm merely just warming everyone up for our main topic, Gigabit Coverage on land, sea, and air. Now, we started back in 2015, actually, with Connect University, which is the knowledge sharing flagship initiative of DigiConnect, which aims to update both the EU staff and you, the general public, about the latest digital trends, as well as important digital policies. Now, the scope of our sessions in general is to put at the same table EU institutions, industry, academia, and international organizations, helping us find inspiration from each other, identify current opportunities and threats to policymaking. For those of you which are not yet connected via Slido, we invite you to do so by going on slide.do, and please use the code Gigabit. There you can ask us questions, and we will make sure that it will make their way towards our speakers. Also, we encourage everyone using the hashtag to Connect University and Digital Infrastructure when sharing any insights that you might find out today or this week on all of the sessions. In terms of recording, for those of you which might not stay until the end, the recording of all the sessions will be available as of next week. So the links will be added in the chat, but please feel free already to visit the Digital EU channel on YouTube, as well as the Connect University webpage on Futurium, where we have, in general, a lot of relevant communities, which we actually invite everyone to be part of, because that's one of the places which we take our inspiration from in terms of future developments, future sessions. So we really invite everyone to have a voice over there. Now, generally speaking, technology moves pretty fast, so we must run alongside with it, having access to the most up-to-date information so we can reach our destinations in good shape. Before we start the core session of today, I want to give you a very small overview of what you might expect in the coming days for the autumn school. So our other future destinations would be tomorrow, also at 10, an overview of the microchips value chain, hosted by Lucila Scioli, Director in DigiConnect on Artificial Intelligence and Digital Industry. Next, in the afternoon at 2, we have the Shift to Edge Data Processing session, hosted by Pierre Chastanet, the head of unit on cloud and software. Wednesday, we start our day with a session on data centers, how growth and greening go together, hosted by Manuel Mateo Goye, our head of unit on cloud and software. Next, on the same day, the session on Web 2 versus Web 3 towards the next generation internet, hosted by Gemma Carrillo. Further on Thursday, we start with a more technical session on high performance computing and quantum infrastructure deployment in Europe. After that, we continue with a session on industrial platform economy, which aims at spurring innovation. And finally, on Friday, the mobile generation game from 1G to 5G and beyond. And of course, the closing session hosted by our director, Roberto Viola, which will basically cover all the important points said in all of these specific individual sessions, and also give us a more holistic view of the autumn school and the relation to policy and concerns and the Commission's plans for the future in terms of greening digital infrastructure. As for our session on today, on gigabit coverage in order to best give a context and shed some light on the topic for non-experts such as I, but of course also for those of you which are more fluent in the matter. We have with us today Rita Bezenbeek, Director B Connectivity, Franco Accordino, Head of Unit Investment in High Capacity Networks, and at the same time, Bram Teithoff, Director Regulatory Policy and Public Affairs at Vodafone Ziggo, Bruce Ho, Department of Oceans, University of Hawaii, and last but not least, Arti Holamaini, Secretary General, Global Satellite Operation Association. So for now, please welcome, and Rita, the floor is yours.
Yes, thank you very much, Alexandro, and also thank you very much for organizing Connect University, of which I know it's a huge task. So, so good to have you here and to have everybody here, the Connect colleagues, but certainly also the non-Connect, let's say, interested people. So great to have this, to be able to share knowledge between Commission institutions and also those who are not inside the Commission but outside. And I particularly look forward to this afternoon, which concerns the connectivity issue, which is in the end a core issue for anything that happens with respect to the digital transition. Because where would we be without connectivity? And that's what we always know very well from our own experience. Now and then standing out on a hill or standing out in the country and having no connectivity. So welcome also to Franco Accordino and his team who organized today's session. And certainly also welcome to our speakers who were already introduced to you, Mr. Teithoff, Mr. Ho, and Mrs. Holamaini. Now maybe before we go over to the presentations, let me give you a very short introduction on where we are with respect to our policy framework, with respect to connectivity. And I do this taking into account that Thibaut Kleiner has already spoken this morning on the more international dimension of this policy and also on the global gateway policy that will be very relevant in particular for the submarine aspect of this afternoon. But just to paint you a little bit the overarching framework, we had a very good day or actually night in the midst of the summer, 13th July, where agreement was reached between the member states and the parliament on what we call the Digital Decade Policy Program. And to us, that is really a game changer. We should emphasize that this is the, let's say, the digital twin of the Green Deal. So this is where we have identified our objectives and our targets of where we think Europe should want to be in 2030. And this is in particular where we should want to be if we want to keep pace with the digital transition also elsewhere in the world. So for this, it is important that we know where we're going and that we are also going jointly. Now, in this context, it's a bit, I think, important to give you the broad characteristics. I mean, the broad characteristics are that in the digital policy program, 12 targets have been identified for this transition around 4 cardinal points. And those 4 cardinal points are infrastructure, digital skills, the digital transition of the public sector, and the digital transition of the business sector. Now, I will not go into the details. We have put at the disposal of member states also quite some funding in the form of the RRF, which is probably well known to all of you, the CEF program, in order to finance how member states can be helped to get to these targets. But maybe to dwell a little bit on the more narrow framework for connectivity, it's important to signal that in the context of the infrastructure target, we have mentioned a target, for instance, with respect to the creation of a quantum computer, but also targets for edge computing and targets for connectivity. And our target for connectivity is that in 2030, we think that all European households should have gigabit connectivity through fixed networks, and all populated areas should be covered by 5G mobile connectivity. So these are our targets, and actually it's going to some extent not so bad. So we see in the figures that in particular in the area of fixed connectivity, more than half of Europe is already covered by fiber. So that's going relatively well. There are big differences. Some member states are over 80%, others are only over 20%. But overall, I mean, with quite some effort, it's possible to reach these targets. 5G is a bit of a more difficult story, it's also not always easy to measure, but also here there is quite some progress as opposed to, for instance, last year. Now, what is key to signal with respect to this digital policy program, and I really want to use today's opportunity to signal that, we live in a new world now where member states have agreed on common targets and they have agreed to work together. And they want to do so on the basis of strategic roadmaps that they will hand in between now and a year. So for all those who are not working within DG Connect, I would certainly invite you to follow progress and also to be heard on the digital roadmaps of your own country. So this is really important. Once we have the roadmaps, then we from the Commission will make an analysis of progress of member states on the basis of these roadmaps, and we will state in an annual report whether we in Europe as a whole are still on target or not. And subsequently, there are all kinds of cooperation mechanisms that enter into force. Now, this, I won't dwell too long. This is the overarching framework. It is important, I think, to know that. But today we're going to focus on the connectivity aspects of this. And as said, we are very happy to have the three main areas represented. For connectivity over land, we have Mr. Tijdhoff, who's the Director Regulatory Affairs of VodafoneZiggo, and who has, as I saw from his CV, extensive experience also in dealing with government institutions, including competition authorities. And I personally am very curious to hear from a densely populated area like the Netherlands, where you would think life is easy for the deployment of fiber, whether that's the case or not. And then maybe before moving over to Mr. Tijdhoff, after him, there will be Mr. Ho, who we know is very knowledgeable and an authority on submarine cables. This is also an extremely interesting area where we see a lot of developments lately, both in the technological sense and in the sense of the composition of the market. And then indeed we will have Mrs. Holla, who is the director of the Satellite Association in Brussels, and equally a well-known expert. And she will tell us about the way that satellites can complement this world of connectivity over land and over sea, and also in a technological equivalence or neutrality approach. I mean, how she sees the role of satellites. So very interesting speakers this afternoon, and I'm happy to hand the floor to Mr. Tijdhoff.
Thank you very much. Thank you very much for this introduction. Thank you very much for having me on this Connect University program. It's quite intimidating to be in the presence of so many experts. I will start sharing my presentation soon. That will be a very tricky moment, as always, because a lot of things can go wrong. But I hope it will go right. I won't see you then anymore. So if there's anything that you would like to ask, I won't be able to see the chat. So hopefully somebody will raise his voice then. I've prepared a presentation about the Netherlands, about VodafoneZiggo as well. That's the company I'm working for. VodafoneZiggo is a joint venture between Liberty Global, the world's largest cable company, and Vodafone Group, one of the largest mobile companies. And I'll explain a bit how we came in the Netherlands to the situation where we are now, which is a very favorable position within Europe, but also within the world. So it's more about a lecture about coming from the past towards now than a very technical story about certain regulations or something. So I hope you'll enjoy a deep dive in history. I'm going to try to share the presentation. and if somebody could say whether they see it, that would be really helpful. Is anybody seeing the presentation?
There is a short delay, I think.
Yes.
Yes, it is seen. Okay, that is great. So yeah, in the course of the presentation, I will speak a little bit more about myself, the company I work for, and the situation in the Netherlands regarding the gigabit coverage. I think the Netherlands is a very interesting case story regarding digital markets in Europe, as the Netherlands can be seen as, say, 1 step, 2 steps ahead of most other member states in Europe regarding gigabit coverage. And I will try to explain it in the next 15 to 20 minutes. First by looking back and explain how we came to the situation that we're currently in, and then also try to look forward into the future and where we are regarding the Digital Decade 2030 goals that Ms. Wezenbeek already referred to. But first, looking back. In the previous century, yes, we're really going back in time, the Netherlands was characterized by a big monopolistic incumbent providing telephony services, and the company that is now called KPN. Television was still provided by a lot of many small cable companies that were even municipality based. So with more than 400 municipalities, you can understand that there were a lot of these very small companies, and internet was still in the infant stages back then. The local cable companies slowly became to merge together. This is a slide, it's not going back that far in time, but you already see that there were very many companies in 2016 which merged quite a bit into the years between 16 and 21. But I'm even going back much further because in 2009 there were slightly more than a handful of cable companies in the Netherlands because they were already merging back then. The biggest one was UPC, Liberty Global owned, and then 3 private companies, private equity companies, bought together some small companies to form the company that was then called Ziggo, the cable company offering telephony, mobile, back then telephony, internet, and television services. And I joined in 2003, just at that moment. So there was an exciting time for the company and for the Netherlands. Internet was already an established force. KPN was offering it via its copper cables, and customers had to dial in via the modem. It was slow, it was costly, whereas the cable companies already were offering always-on internet via the cables that were in the ground, that were originally dug into the ground for television, but were technologically so advanced that they could also offer telephony and internet. So the competition was heating up. Then the formation of Ziggo came by, and UPC was already quite big. So there were 2 companies in the Netherlands that were offering cable services. But KPN, of course, still had the big advantage of being a national company. But because the cable companies became stronger and stronger, KPN had to react. And a shift from ADSL, which is a technology used over the copper cables by KPN, was switched to VDSL, which is more advanced and could offer higher speeds. And the first steps in FTTH, so fiber, were made. Ziggo became a stock-listed company, lasted for 2 years. Then Liberty Global, the owner of UPC, I mentioned before, came along, bought the shares, and became the sole owner of both Ziggo and UPC. And they were merged. And then for the first time in the history of the Netherlands, but also in Europe, there were 2 nationwide competing networks going head-to-head, offering both fixed telephony, television, and internet services. So the heat of the competition increased even more. And the motor of this competition was all-in-one, offering 3 products together in one package, internet, television, and telephony, which was offering better prices for customers and better services. As said, KPN went from ADSL to VDSL, higher speeds, and cable went from DOCSIS 2.0, which is a technology, you don't have to remember it, because only that it then went to DOCSIS 3.0. And that meant that the competition was even getting heavier and heavier. And the next slide, which will come up now, is not to be read. It's way too small, all these letters and the text. But it shows that each company was reacting to the other company just because of the competition. And what you then see is that what we call the leapfrog effect, you constantly try to outdo the other. So if KPN put something new on the market, then either Ziggo or UPC or the other companies also try to outdo the others. And that's why we had such a high grade of new introduction of products, better prices, etc., etc. But KPN had one advantage over us still, and that is that they had a mobile network. That's not what I'm going to talk about today, but that was the reason that we then tried to merge Vodafone, which is of course a mobile company, probably known in most of Europe, together with Ziggo. We called it conveniently Vodafone Ziggo. And now we had two companies really going head to head on all cylinders. But still there were a lot of other companies like T-Mobile, part of Deutsche Telekom back then, who were also having their own networks then for mobile, and other companies that were also offering internet services, which mean that they still had to compete head to head. And the consumer was and still is the winner, I would like to say. And in the meantime, and almost offhandedly, all goals of the European Commission and the Dutch government regarding internet speeds were easily met. So the goal is to have 100 megabits per second in 2025, which was already reached years in advance. And also the digital decade goals, especially the aim to offer gigabit speeds to all households by 2030, are already almost met or within reach, years before the deadline. Vodafone Ziggo will be offering gigabit speeds nationwide by the end of the year, so this year. KPN, T-Mobile, Delta Fiber are rolling out fiber networks at breakneck speed, and KPN expects to have 85% of the Netherlands covered with fiber by 2026. So that's only 4 years from now, and still 4 years before the deadline of 2030. And that is what is still happening. So the introduction of fiber also leads us to introduce what is called DOCSIS 3.1, which is a better technology than 3.0, which increases speeds and capacity even more. And in the meantime, we also have been going from 2G to 3G, 4G, and 5G on the mobile side. But it's fiber rollout now in the Netherlands, especially for our competitors. As said, we will reach 100% gigabit coverage by the end of this year. The other companies can't do that on their copper networks, so that's kind of an older cable. So they're digging fiber into the ground, and that goes very quickly. And we have several parties doing that at the same time. So KPN is the largest, but also ODF, of which T-Mobile is the tenant anchor, is going to create 1 million homes in the Netherlands. Delta, owned by private equities, aiming for 2 million homes. They have some smaller companies that are also aiming for 500,000 or even more homes, which is interesting because in the Netherlands we only have 7.7 million homes. So within a few years' time, we have more cable connections in the Netherlands than there are actual homes. And we have the HFC, the hybrid fiber coax network of Vodafone Ziggo, also reaching all these homes. So there's a lot of competition going on. And that means that we will reach the digital decade speeds very easily and way ahead of time. But of course, government intervention also played a large role in getting here. deregulation started in the 1990s. New players were allowed on the market. I showed it earlier. And that meant competition. And that also meant that we had to push each other, and that meant that we're now in a place where the Netherlands is third in the overall DESI index, the Digital Economy and Society Index, and second on the connectivity level, just behind Denmark. So the competition is a very interesting force, because it meant that the regulation that was in place in the Netherlands, especially in the 90s, in the first 10, 20 years of this century, was less and less necessary. We're now in a situation in the Netherlands which is very interesting, and well, I hope for a lot of other countries in Europe something to look forward to, that there's hardly any regulation anymore on fixed networks. And that is to say, the Dutch regulator, the ACM, has recently agreed to watch over a voluntary offer of KPN to allow third parties access to their networks for a fraction of the previous prices. This is a voluntary offer valid for the coming 8 years on favorable terms. So the competition is guaranteed until 2030. This is something that is not completely new in Europe. Denmark, I think, has the same situation, but it is something that has been something that we all wished for. I think both on the regulator, the government side, but also on the business side, that less regulation is needed because the competition is so fierce that things sort themselves out anyway. For the more technically people that know more about telecoms regulations, there is still a market analysis in the Netherlands going on that could still conclude that there are some problems on the market that is not solved by the voluntary offer of KPN. So there might be something in the books that we will then hear in the coming few months. It's not expected, but regulators have surprised us more often, so that might be the case here as well. But then there is another rule has come into the market, Article 61.3 for the people in the know, which introduces what is called symmetric access. And that is in place for a situation where you're in a rural area where there's only one network, and it's very costly and economically non-viable to lay out a second network. Therefore, this article has been put into the EECC, the European Electronic Communications Code, that is now available or present in almost every member state, which allows a company to request access to a network if there is no viable economic reason to lay out their own network. And we have such a company in the Netherlands that is requesting access to our network. And that is quite surprising. Not so much that they request access, but that they request it for a city that I think most of you know and would not classify as very rural. That is namely the city of Amsterdam. And a city that has several networks and where fiber is also being rolled out, but still they request access. We are very curious to see how the regulator is going to react. Well, let's see. It's a new law, so it's also a new situation in Europe, and we will be the first country that will put this on the table, also for the European Commission to look into. But you could also say, yeah, these are the last struggles to have good internet everywhere. And whether that needs to be done via our network or not remains to be seen. But in the meantime, and I'll just shortly say something about it, competition is not only national anymore. The OTT market has also come to play a big part. and creating a completely new level of competition. And of course, you know, the companies, I'm looking at my screen, I don't see Netflix here, but of course, there's one of the main new, well, not new anymore, but driving forces of this OTT bonanza. Changing the landscape, especially on content consumption. And that not on a national scale, as I said, but also on in an international, even global scale. And as the Netherlands is the first country where, is often the first country where new technologies and services come to Europe, we have been on the forefront of these developments, which are very interesting, but also driven by the fact that from a long time ago, the sea cables landed on terrestrial Europe in the Netherlands. We have the M6 in Amsterdam, which is kind of a peering hub, the largest in Europe. And that is a crucial role for internet connection. And since that we have that in the Netherlands, we are also there for in the forefront of all the developments that are happening there. I think the next speaker already will delve deeper into the intriguing world of the transatlantic sea cables. But that is something that is also happening now that we're also dealing with and creates a completely different kind of competition and a lot of interesting questions that also remain to be solved. Because it also leads to an incredible amount of data that needs to be transported over the networks. And most networks are capable of doing that. I think the litmus test was the COVID crisis, when everybody started to work from home and everything needed to be done via internet services. And I think in most European countries that went very well, in the Netherlands too. So we were very lucky to have one of the best networks in Europe, in the world. So we can also easily manage all these OTT providers. But that is happening now. Let's also look a bit into the future. And this is the last slide that I want to present to you, the digital decade. Because as said before, there are very good goals for 2030, but we're actually meeting them already at a very high percentage. You see in the legend that it's internet coverage of 100 megabit, 99+% in most of the Netherlands. And at the end of the year, that will also be the case for gigabit rollout. And the strength of the competition and the companies that are trying to outcompete each other with the leapfrog effect has led to this situation. And I think that is a very favorable one, and very much helped also by the European Commission, by the very different, well, not different, but the many regulations that have been put in place that helped us to create this situation, which I hope will also be the case for the rest of Europe. I think I'm already, I'm reaching my 20 minutes time. So with this very happy note that we're already almost there, I would like to give back the presentation to you. So I'll stop sharing my screen. Then I will be back into the room and then probably give the word to Bruce.
Yes, thank you very much, Bram. Indeed, a very enlightening presentation, also, which already we think gave rise to some intriguing questions. Now, in general, we have decided to have the questions afterwards, which would also allow the audience to see the links between the various areas. So if you don't mind, and you will stay around until the other speakers have done, then we would be very happy to indeed move to Bruce to hear about, as you said, the exciting world of global gateways. Yes, Bruce, over to you.
Yes. Okay, just a second. There, can you see that and hear me?
Yes.
Okay, good. So greetings and aloha. I'm in Wellington, New Zealand. It's 1:30 in the morning. I'm pleased to be here with all of you. I'll be talking about using submarine cable networks to extend our sensory capabilities to observing the oceans and Earth as part of the humankind nervous system, if you will. The Joint Task Force for Smart Cables, Smart Stand, sponsored by the International Communications Union, World Meteorological Organization, and the Intergovernmental Ocean Mission. So I'm giving an overview of the current state of the international submarine telecommunications network that connects the world together, and has become very clear during COVID the absolute need for this. First, submarine cables effectively carry all internet traffic by volume. The network is constantly being refreshed and extended. It is highly reliable with 25-year life or longer. And it's a major industry of $5 billion or so per year, 5 billion euros now, and with 170 years of experience. Owners include telecom consortia, private entities, content providers like Google, and governments as well. Up until now, and for the last 170 years of using the seafloor, cables have been deaf, dumb, and blind to the environment. So let me show here. Let's take the telecom only map that I showed before and conceptually add smart sensors along all the cables represented by the dots here. And to obtain a planetary scale sensor network that provides power and internet connectivity that can observe the climate, oceans, sea level, earthquakes, and tsunamis. We will share the submarine telecommunication network that links countries and continents together, and as we all know, enables our society as we know it today. And telecom is a primary mission with smart secondary. The basic sensors we're talking about are ocean bottom temperature, pressure, and seismic acceleration. And they would go in these repeaters that are along the cables roughly every 70 kilometers or so, with access to the fibers, communication, and for power. And these sensors can improve our knowledge of the cable's environment and thus their integrity as well. A number of systems are in various stages of planning, requests for proposals, and implementation. The green circle off Europe indicates the CAM system underway with smart capability in Portugal's Atlantic domain. And we expect smart cables to evolve into a major addition to the ocean and Earth observing system. So I'm just stating what we now and increasingly so know that climate change is humanity's greatest existential threat. And with this capability, extending our senses, so to speak, out into the environment more directly and so on, we can observe climate change, ocean temperature, heat content, circulation, sea level rise, hazards to coasts and islands, disaster risk reduction, tsunami and earthquake monitoring, and as well as improving social connectivity, because we'll have a more resilient cable system. And these will address SDGs and so on. Just to show a cartoon here of how this fits together in the present observing system. As the climate situation becomes more and more dire, it'll be important to constantly improve the observing system. Here we have satellites, we have other instrumentation in the ocean itself, and really the smart cables will lie along the seafloor, obviously, and measure essential ocean variables and provide the bottom boundary condition for the ocean. And they'll complement the satellite and other in situ observing systems. Nothing stands by itself here. And here, just showing a little more detail about the actual sensing. Deep ocean temperature is increasing 50 millidegrees per decade. That's a red color in this top map down here in the deep ocean. And ocean bottom temperature will contribute to better estimates of heat content and storing of the heat that we are generating in the atmosphere goes into the ocean. 90% of the heat from the atmosphere makes its way into the ocean and therefore keeps the atmosphere cooler. And the same for CO2 for that matter, makes the ocean more acidic. And by measuring deep ocean temperature, that's a impact on sea level rise because seawater expands with increasing temperature, and it also affects the circulation. Bottom pressure increases due to melting ice from land ice and ice sheets on Antarctica, for instance, increasing sea level. And then water flows from high pressure to low pressure, so it's a way of measuring parts of the ocean temperature or ocean circulation. And ocean bottom pressure and seismic acceleration will significantly improve earthquake and tsunami early warning. The red symbols on the map here are earthquakes, historical earthquakes. And initial tsunami warnings based on seismic data have large uncertainty. And so in situ pressure measurements, direct measurements of tsunami waves will improve the predictions of tsunamis. And then lastly, we'll simply learn more about the interior of the Earth from all the seismic data. This schematically shows what a tsunami early warning center would see as a function of time. In the left plot there, besides the earthquake and tsunami off Japan, there are 3 hypothetical cables going off there with sensors in the cables, and these are the traces. So it's real-time, reliable, and in situ measurements. This slide comes from Alcatel Submarine Networks. They are the world's largest supplier of cable systems, and they have publicly stated their intent to provide smart capability, and they are presently already working on integrating sensors into one of this is their repeater, and so they expect to be ready in 2025 to deliver systems with this capability. The next 2 slides show some of the systems that are under consideration, underway already, and so on. In the middle is the wet demonstration project off Sicily, and test smart repeaters are due to be installed in 2023. In the green box on the left, the CAM system is largely motivated by the 1755 earthquake and tsunami that destroyed Lisbon and much of the Portuguese coast and North Africa as well. And here the government is requiring smart capability with installation in 2025. It's been the regulatory agency ANACOM that has played a crucial role here. And they've also done studies, the value of lives saved in a 1755-like event in the 25-year life of the system will more than compensate for the entire capital cost of the cable system based just on earthquake effects and not yet including tsunami effects. In the right blue box, there are efforts underway to raise the incremental funding, nominally 10% of telecom cost, needed to include smart capability in the Medusa system connecting Europe and North Africa. In the Pacific, where I am now, on the left, I show a modest cable system between New Caledonia and Vanuatu. And Vanuatu has a dubious distinction of being the most disaster-prone country in the world, with volcanoes, typhoons, earthquakes, and tsunamis. And so they really need early warning for those, at least for the seismic and tsunami part of it. We are working with funding from the Gordon and Betty Moore Foundation to implement such a system there. I'm here in New Zealand, and they are considering a domestic cable from North Island to Chatham Islands to serve a remote community, and at the same time make these scientific and early warning measurements. On the right-hand side, there's the proposed cable systems going to Antarctica. Antarctica is the last continent that is unserved by submarine telecommunication cables, and that is likely to change in the near future because satellite connectivity is abysmal in the polar regions, and so just to keep people working happily, you have to have connectivity these days, let alone all the data and logistics and so on. So the U.S. National Science Foundation has proposed connecting Antarctica and New Zealand for internet connectivity and smart. A feasibility study has just been completed with positive results technically and financially and so on. So this is government, U.S. government, big, so it might take 6 or 10 years to implement, but it will happen, I'm quite sure. And then also there's a proposed cable from southern Chile to their bases in Antarctica as well. So that's, there will be links to Antarctica. And in the lower right, Far North Fiber will link Europe and Asia through the Arctic region. They will accommodate smart, given incremental funding. In Australia, there's Project Coede going from Perth to Darwin and Malaysia, as well as serving Australian offshore oil and gas mining and the square kilometer array and so on in Australia. Indonesia is developing in-country capability, starting with short single-ended cables. So let's move back to Europe here. And this is prompted by a webinar just last week given by Thomas Kupfer. And I just extracted one slide, part of a slide there, saying that in future, the next call for funding through the CEF2 program, smart cables will be included, and draft text says costs related to integrating sensors into submarine cable system are in the scope of this call. But the main purpose, as sort of the topic here, is this funding will help in the submarine cable world to provide international digital connectivity for the entire European Union, and part of that is supporting territorial cohesion, if you will. So it's covering all the European Union, and a substantial amount of money, hundreds of millions of euros are involved. And the first call has been complete, and the second will come out expected in October. And very well, for depending on the kind of project, it's between 30 and 70% support, if approved, obviously. And importantly, it does address connecting outermost regions in overseas countries and territories, and the map shows some of these here. And so that helps give a global extent to Europe, basically. And for us with smart cables, that's our ultimate goal, is to have global coverage and global scale coverage. And this European Commission funding and this structure of it is in our opinion, a good precedent for other organizations to follow as well. And it's basically saying 2 for the price of 1. So let's see, I think there. So just in, excuse me, in conclusion here, SMART is needed to better measure essential ocean variables and to contribute to disaster risk reduction. And think global scale, power and internet on the seafloor, sustained real-time, 25-year life, highly reliable, and leverages this $5 billion per year industry with long experience and with a low lifetime cost. There are systems or providers that will provide this capability in the 2025 timeframe. And there are a number of systems underway or under consideration. SMART is reasonably well integrated into these UN organizations, and we are working towards, again, this global scale coverage. And part of this is we have to always remember to keep it simple in order to achieve that global goal. But the main point here is that Europe is taking a leading role with the European Commission and with Portugal leading, and I certainly hope that will continue. I expect so, and look forward to the next decade where there'll be many more cables going in with sensing capability that'll help really connect us to our entire world, not just human beings together, but the world itself. So can turn it over now. Let's see.
Thank you very much, Bruce. This was a very educational presentation indeed, and certainly for me. I'm happy you also lived up to our original title of showing sustainable connectivity, and you were able also to inform us about all the additional capacities of cable infrastructure. So really interesting. Thank you very much also for shedding light on Europe's role, and mostly so for being here at this hour at your place. So thank you very much. Now, I would, in line with what we said, I would indeed propose that we now move on to Artie, so that the questions will come from the overarching holistic perspective of all the 3 elements. So thank you very much. And then Artie, over to you.
Thank you very much, Rita. Well, I hope everybody can see my slides. Thank you for inviting GSOA to be here to participate in today's session. Delighted to tell you, to share our perspective with you. And for those of you who don't know, GSOA used to be ISOA. We used to be the EMEA Satellite Operators Association. And in just January, we became global. So we represent 29 satellite operators. Some of them are global companies, household names. Some of them are regional flagship operators. And the association is CEO driven. I wanted just to start by making the point that satellite continues with all its innovation and changes that are happening in the sector to embed its role into the broader telecoms landscape. It is highly relevant in the post-pandemic world, which is at the same time facing climate, security, and economic challenges. And it's absolutely critical also to making Europe what I would say technologically superior in today's globalized world. I had wondered whether to write technologically competitive or superior, and I think superior is a good one here. The importance of satellite is being increasingly recognized by decision makers and influencers, but also by market players, by vendors and mobile operators in particular. The technology and the services coming from space are highly relevant for the EU to achieve both objectives that it has set for itself historically, but also to support the achievement of future digital and industrial objectives. And of course, to ensure an inclusive and resilient society. The first thing I wanted to highlight was political objectives and real world challenges, and just put those out there because I think this is something that we don't often talk about, but probably we should. If we look at it just from a political point of view, then we can judge Europe actually a little bit harshly, because all of the digital targets that were set for connectivity for all since the digital agenda for Europe back in 2009 have actually not been met, whether it was basic broadband for all, or 30 megabit per second for all, or 100 megabit per second for all. But now we have even more challenging targets with the Digital Decade 2030, namely, as Rita said, gigabit connectivity for all and 5G for all populated areas, etc. The Commission has, however, recognized, in addition, the importance of next generation satellite capabilities as well. And it would be amiss not to refer also to what I call the Breton initiative with DG DEFIS, the secure constellation of satellites. The evolving targets that have been set by the European Union are, however, being matched by evolving satellite systems, specifically reach, resilience, reliability, and of course, security. The evolution in satellite systems has been quite stark. In fact, we've seen more evolution and innovation in the last couple of years than we have over the last decade. There are hundreds of traditional satellites that are still providing significant throughput globally. And they are particularly good, of course, for broadcast, but also for global IP data communications. But now we've entered the era of high throughput satellites, and each one of those is delivering hundreds of gigabits per second. Existing and planned non-geostationary satellite constellations are each talking about bringing terabits per second connectivity as well. So overall, you can see that besides coverage, the satellite offering is growing dramatically to meet the diverse 5G requirements. And in addition, I wanted to point out that Europe now has its first very high throughput satellite. When you look at the globe, if you were to look at a map of the globe and you look at the different satellite capabilities, in the US, they have had VHTS capabilities for a very long time. So 100 megabit per second, 150 megabit per second broadband communications for all is nothing new over there. In Europe, it has taken a little longer to develop, but we have those speeds now. And we also have our first very high throughput satellite as well. When it comes to the key strengths, I think here we need to talk about what society is really concerned with. With the experience that we've all been through with the pandemic, I think that a digitally divided Europe is no longer acceptable. It's not acceptable for the electorate. It's not acceptable either for governments. MNOs also have started to partner a lot more with satellites to deliver on their coverage obligations. And in the wake of the pandemic, with all of the 5G licenses that we see now being given for use of new spectrum, we see also an increase in the obligation on MNOs to deliver on coverage. So this provides a good pull, a push and a pull on the satellite sector to deliver more, and on MNOs to really foster the partnership there. The potential market in key verticals is also one which requires satellite connectivity. Whether we think of healthcare, education, or mobility, many of these sectors require uninterrupted connectivity, and it cannot be disparate between urban and rural areas. As the quantity of data is increasing that is being transmitted from A to B and also from the European Union outside, and as networks start to converge with integration and so on, the cybersecurity concerns are also increasing. This is another area where satellite comes to its fore. satellite control systems are typically only connected to private networks and not to the internet. And there's also a lot of research and development in quantum key distribution, which is having a dedicated focus on SATCOMs. Of course, the resilience and reliability of networks is also essential for key verticals. As has been mentioned by Mr. Howe, the reliability and the disaster resilience of satellite networks remains essential. And satellite systems are designed from the outset for high security markets. The critical markets they serve are military, government, oil and gas, finance. It is only in later years that the more commercial markets started to emerge. The market requirements that we are seeing are matching the satellite strengths. The first one is in the field of connectivity for all, so satellite broadband. During the pandemic, the operators, our GSOA members who are providing satellite broadband, saw a 70% increase in the traffic over those connections. And indeed, they saw a wave of new subscriptions across Western and Central Europe, to the point that the satellites that were providing this connectivity were saturated. They were not able to deliver more connections when they were being demanded. The highlighted countries there are Hungary, Ireland, Italy, Poland, Spain, and the UK, no longer part of the EU, but still. At the same time, we saw a lot of additional capacity being requested by mobile operators who were relying on satellite for satellite broadband. And it wasn't just at peak times. And this is obviously because more people were working from home, and so it makes sense. At the same time, I wanted to mention the use of satellite for backhaul to deliver on coverage and resilience requirements. This is an example from the UK, but it could equally apply to any other country. But specifically, the lesson learned there was as a result of the emergency services network. BT was required to deliver 94% coverage of the country. And the only way that they could do that was by leveraging satellite backhaul. And they found that by using this, they managed to significantly increase the uptime of their network overall, because even terrestrial networks face outages and more frequently than we think. And BT said that as they start to deliver more reliable and ultra-reliable services in the context of 5G, they will be making more use of satellite technology. And in fact, the space-based component makes it easier for them to decouple the failures in their terrestrial network. In the future, they're looking now at how they can leverage the VHTS and the NGSO systems to deliver more high reliability services. Another example is from Virgin Media O2. Virgin Media launched Project Darwin, the Darwin Innovation Lab, in the UK. And they're launching a similar lab now in Spain. And this was the first commercial satellite 5G lab, which allowed companies to test autonomous vehicles and proofs of concepts that rely on connected and autonomous vehicles. The COO of Virgin Media O2 noted that this is the next step in getting autonomous vehicles on the road and making the transport network greener. So you can see how this will also contribute to the green objectives. So we're supporting the realization of one of the key 5G verticals, mobility, supporting the move towards a greener autonomy. And in addition, Virgin Media O2's own research showed that CAVs to be more cyber secure thanks to the use of SATCOMs, and less cyber secure if they relied only on terrestrial networks. Of course, it's not just about connectivity, it's also about IoT applications and imagery. So many of our members are involved in different projects, whether it's in the fields of agriculture and precision farming, or IoT-based solutions to support sustainable uses, again, in the fields of agriculture, but also in the field of aviation and reducing carbon emissions and CO2, etc. The developments that I've been talking about on the service side are very much supported by technical developments on the standardization front. So we have been members of 3GPP as market representation partner for a few years now. And the latest release 17, which was published earlier this year, came out with two specific specifications to support non-terrestrial networks. The first is 5G new radio over NTN, and the other is NB-IoT over NTN. The 5G new radio over NTN is absolutely fundamental for what we're seeing now as the holy grail of SATCOMs. So direct access, the potential to connect smartphones directly to satellite. And there are a few mobile operators, a few terrestrial companies who are really investing into this. So we have Orange, which is partnered with AST Space Mobile. We have Apple, which is partnered with Globalstar, and T-Mobile, which announced a partnership with SpaceX. So we have a lot of our members who are exploring direct access, whether it's to smartphones, whether it's to connected vehicles, or whether it's to IoT devices. And it's worth noting that Release 17 has the technical requirement for mobile chipsets to support the direct-to-cell phone capabilities. So now it's over to the market to start taking this up. But what we do see is that it works. The testing, the trials have shown that direct access is real. It does work. So it's a question of time until we see that the market takes this up. But of course, none of these developments can happen unless you have the support of the market operators. And to that end, GSOA entered an MOU with NGMN, the Next Generation Mobile Network Operators Alliance, back in 2018. And without their support, the specifications in Release 17 would not have emerged. NGMN issued their own position paper on NTN, and in that they assessed a variety of verticals and how satellite connectivity would support them. I'm providing the link for that so you can have a look at that in your own time. So based on all of that, this is our vision for satellite in the networks of tomorrow. You have capabilities coming from different orbits. You have integration into terrestrial networks thanks to standardization. And you have a lot of different types of services being offered, also using multiple beams, different frequency bands, and different access technologies. But it's not stopping there. We've already started working on Release 18, so enhancements of the standardization specs that have come out so far. And the focus there is on mobility. So VSAT eSIM devices with directive antennas. That seems to be where the greater demand is for now. But I don't want to read you the slide. There's a lot of technical information which is available there. But safe to say that Release 18 is going to support even further satellite and terrestrial network integration. The vision of the sector goes, of course, beyond that. We're living in a telecoms ecosystem, which is also starting to talk about 6G. So whereas with 4G, we saw interworking between satellite and terrestrial players at the IP level, with 5G, we now see the emergence of the standard. So we're looking at integrating networks. And with 6G, we're talking about unified networks, where there really is no differentiation between terrestrial and network and satellite from the user perspective at all. So the sector continues to innovate in its bid to help achieve global connectivity. And with that, I conclude my presentation. Thank you.
Yes, so thank you very much, Artie. This has really taken us in a tour around the world, both, I would say, physically to New Zealand and also to space. So thank you very much. Very enlightening, very interesting. I have a number of questions, but I would first of all then give the floor to the audience. And Franco, who is sitting next to me and who has, with his team, organized today's session, has volunteered to monitor the discussion from on the basis of the questions from the audience. So I think, Franco, we should probably ask you then to guide us through the questions. No?
Thank you, Rita. Thank you also on my side to the speakers and the audience as well, because we have had quite a lot of questions posted on Slido. It's a quite interesting and exciting session, I must say this, because it spells out really what are the challenges ahead, the vision in some cases, and also what is also our role, Rita, no, in supporting all of these. So here I see, for instance, just because now we have all the three air, land, and sea together, so we need to try to group maybe the question in a way that can be more easily answered. One question posed by Matteo Mascagni. Thank you for that, Matteo. Say, I was wondering if the technology used has been fully deployed, developed, and also manufactured in the EU. So he posed this question in the context of the sea connectivity. So the question would be more for Bruce. So if the cable sensors technology is a technology that is, let's say, also manufactured in Europe. But I want to couple this also with another question, which is more technical, also addressed to Bruce, I would say. When you speak about the 25 years obsolescence or so you mean that this is a guaranteed, I mean, for 25 years you have a guaranteed, let's say, fully functioning cable, and how can you measure these? Also, if you envisage using the sensors themselves as a kind of also devices that can allow certain self-offset diagnosis of what's going on in the cable, in addition to, of course, the beautiful, let's say, properties and applications that you have illustrated to us. So if the use of the sensors themselves within the cables, with these units that you have shown to us, can somehow be used to improve the resilience of the cables themselves. So those two questions altogether. So it's about the maintenance of the cables, the diagnosis, troubleshooting, replacement, related costs, and of course, who is manufacturing them, which is very important for us.
Yeah. Okay. So yes, the present nominal lifetime that all the suppliers have for their cable systems is 25 years. And typically what that means is that there's one, depending on the length of the cable, 1 or 2 repairs in 25 years. And that includes fishing, and any technical faults and so on. So it's not like there's zero, guarantee. But a very, very small number of failures, and Alcatel claims, that none of their repeaters have failed in the water, for instance. And I think the other companies say the same, or something very close to the same. Now with sensors, the history of the scientific sensors is not so long or extensive. I mean, the sensors are relatively new, let's say. And so, when RFPs are actually issued and so on, there'll have to be negotiation on what the statistical requirements are. So, for instance, at the end of 25 years, maybe 95% of the sensors are working, something like that. But that is still considered excellent from an oceanographic and early warning point of view. And then the other part of the question, I think, was how can this actually help the cable systems themselves? Well, yes, the sensors we're suggesting that are in the repeaters, they have some, let's say, spatial extent. And so if there's any changes in their environment, within some radius of a repeater, which are spaced every 70 kilometers, then they'll be able to sense that. So if there's bottom trawling even within 10 kilometers of a repeater, the accelerometers will pick that up. They can't cover everything though. There are new methods, optical fiber sensing, that are coming, that are in a research mode that may hold promise for increasing the or adding basically additional sensing capability to the cables themselves. And some of those optical fiber sensing techniques could apply over the entire length of the cable. The spatial resolution is still to be determined, but if there was any bottom trawling, fishing is the #1 hazard to cables, and that could absolutely be picked up by these new optical fiber sensing techniques. So I think with the sensing, one can improve the integrity of an individual cable, but then also with all the additional geophysical information in general, one can better plan cable routing and so on to avoid some, let's say, geophysical hazards and so on. So in that sense, it can help create a more resilient system. I hope that answered the questions.
Yeah, but there was only one missing, unless so you said something about the supply of intelligent cable systems. Whether or not there is a polarization of supply in some particular region of the world, or we have also some strengths in Europe.
So yes, the one company has publicly stated 2 years ago their intent that, well, first of all, their recognition that climate must play a strategic role in their entire business. And one concrete example they publicly stated was the provision of smart capability, as well as this optical fiber sensing. So Alcatel is the largest supplier of submarine cable systems based in Europe. And the other companies are saying, well, when let's say the Portugal RFP comes out, they will respond to that, as they best see fit. The other companies, Subcom in the US, NEC in Japan, HMN Technologies in China, and Xterra, UK, US, they all have the technical capability to do this. And it's up to them to, when money is on the table, for them to make a decision, how they'll respond. But Alcatel is absolutely on board and progressing. They're already doing engineering work.
Okay, thank you. Let's stay a little bit still in the area of submarine cable connectivity. So according to your experience, what is the additional cost you have to consider when deploying an intelligent cable system as compared to a dummy one, let's say?
Yeah.
Totally passive one, let's say.
Yeah, we're saying a nominal 10% incremental cost over telecom. So the Portuguese system, let's say, is 120 million euros total. And so 10% of that is 12 million euros. So 12 million euros for the smart part and 108 for the telecom part. Now, these are rough numbers, and we'll they'll be proven by example when it's done. And for short systems, there's a baseline cost of maybe, let's say, $5 million. And then as you get to longer system, it approaches 10%. So it's on that order.
I see. Thank you, Bruce. I mean, the message is as the bulk of the costs are anyhow linked to the actual physical deployment, the anchoring, and the study part, etc. Of course, I mean, it's worth to add the 10% more to get something which gives far larger advantages than just
exactly
right. Transmitting data from one end to the other end of the ocean. Okay, so message taken from that point of view. Very good. Still around the submarine connectivity, I see here a question by Anonymous. It says, what is the state of collaboration between the US and the EU concerning the submarine cable connectivity? So what can you tell us about the EU-US collaboration on cabling? Do you want to say something, Bruce, on that?
Well, I don't feel I'm qualified to talk about the connectivity collaboration aspects of it. That's beyond my expertise, I think. But
that's okay.
So
well, Well understood. I can maybe try to answer the anonymous on that. Indeed, indeed, yes. I mean, international collaboration is really at the forefront of political interest in this moment, precisely encoded into the global gateways policy, which has been adopted, if I'm not wrong, 1st of December last year. And within that framework, I think, yes, to spell out really more concretely the type of collaboration, there is a Trade and Technology Council going on, which is discussing many type of collaborations on the digital sector, in particular on submarine cable connectivity as well. So that is, of course, I cannot say more at this level, at this stage, but certainly, yes, it is part of our interest, and there is a reciprocal interest from the US side on having collaborations on concrete projects on that level as well. Then let's move now. Rita, is that okay? Or I think we are still on time, right? We have still plenty of time to have.
I think we have
good
time.
debate.
Yes, please. Yeah.
Yes, and please feel free also, the speakers, to ask each other questions, because indeed, one message we are getting from this session is indeed the fact that there are several type of technologies and systems to connect. First of all, we have seen at the beginning the VodafoneZiggo presentation, which is more about certainly access type of networks. Then we have also the backbone connectivity and the satellite, which is certainly also access at the same time, is a specific type of technology capable of reaching every single corner of an entire area, irrespective whether or not this is populated. So now the question maybe here is more to I would say to Bram. Many thanks, by the way, Bram, for the big effort you have made in the Netherlands to deploy and to ensure that there is a great coverage performance made by the Netherlands in the last DESI index. However, we see there is a little bit of mismatch between the deployment availability of networks and the actual take-up. So the question is, in your view, but I think the question is also related to the other speakers, is whether or not member states and regions or whoever has the ability to invest in public funds in deployment of networks, whether or not linked to coverage measures to deploy the actual networks, states should also look at the take-up measures. And perhaps bundle the two together to ensure that whenever you have a network deployed, you have also users capable of using it. So what is there? The question is, what is the articulation there with respect to the normal dynamics of the market, which should alone normally, particularly in the context of the Netherlands, should bring this to the users at the same time, regulate itself and converge around an offer that is affordable to the end users at the same time. So this is the first question for you, Bruce, please. Sorry, sorry. I see the name Bruce there.
Yeah, no problem. Now, that's an interesting dynamic that is playing out in many member states, but certainly in the Netherlands. If you have already networks covering the whole of the Netherlands, and then you're going to dig fiber, or to roll out fiber, that means that you're going to overbuild on existing cable networks, either cable or copper. And especially if more parties than one are rolling out fiber, that means that several households, or a household can get several different fiber providers. And of course, a household is not going to take up on every fiber provider. So mathematically, you will not get 100% take up of fiber, because there are several fiber providers and a cable provider like us. And there's also the time lag effect. If you roll out fiber now and customers already have another subscription, they won't immediately switch over, especially since fiber providers are not forcing you to take their product once they roll out. They just roll out and try to get you onto their network. But since most people already have a very good coverage, they're not going to switch over immediately. So the situation might be that in a certain time frame, a year, 2 years, 3 years, you will see that the take-up will increase because people are going to switch off certain networks, and ultimately KPN, for example, is going to switch off their copper network. But in the meantime, yeah, there will be more rollout than there will be actual consumers on the networks, if that answers your question.
Maybe can I give a follow-up question,
please.
Bram? So what does that mean for your prediction for Friesland and Zeeland, which I saw in your picture? I mean, do you mean that there's hope that within a limited number of years they will also have good coverage, like gigabit coverage? Or is there a risk that they will never really be served with gigabit coverage?
Zeeland is a province in the Netherlands, one of the 12, in which Delta is laying out fiber at the moment. They have a cable company there, but they're rolling out fiber in the whole of the province. So within a few years' time, I expect that province also to have very high capacity networks, which they already have because they have HFC, but also full fiber. In Friesland, and in the north of the Netherlands, that is most likely also the case. Of course, there will be some households that will not have a very high capacity network. That is estimated to be 20,000 in the Netherlands. So that's not very much compared to all the inhabitants in the Netherlands or in Europe. But these are so hard to reach that is just too expensive to roll it out, especially by market parties.
And then would you then also rely on cooperations with satellite companies, for instance, or for the Netherlands, that's never worth it?
No, that is probably never worth it. We hardly have much satellite in the Netherlands because, yeah, we are not such a... Well, satellite works especially well in rural areas or in areas that don't have very high coverage of either fixed or mobile networks. But the Netherlands is in that sense an exception with exceptionally high coverage, both mobile and fixed.
Thank you, Bram. Concerning your previous point, indeed, your answer is somehow encouraging, at least from the side of policy making. Okay, aside, meaning that the supply, I mean, the operators in general, they decide to whether or not they are vertically integrated or wholesale only, whatever. They invest and they say, okay, fiber is an ultimate technology. In the end, sooner or later, these will bring us returns, revenues. But it's just a matter of time. Now, I think what is quite interesting here that is the speed by which this transition to fiber to one point in time will take place. Because if I'm not wrong, the cable operators, little by little, you mentioned yourself, I mean, when you said that we are moving from DOCSIS 3.0 to DOCSIS 3.1, which we can push to gigabit performance, indeed. But still in 3.1, you still have a certain percentage of coax technology with the proper, introduction of proper error detection and correction technologies, so more sophisticated type of managing of the available band and spectrum within the cable, etc., etc. So now the question is, what is the speed that you envisage for cable operators to ultimately complete their transition? Because ultimately this transition seems to be unavoidable, if I understand correctly. So how they are tackling this dilemma, say whether or not to invest now. As you said, okay, we invest, we don't know whether or not there will be in the end ultimate take up, but there will be it because it's an ultimate technology, or it will take it more slowly. For us, this is important because actually we are not in a hurry now. And this links to another question, by the way, about what is different now with the connectivity compared to the digital agenda, the target we set for the 2020. I think now what is on our side is that we know we have some lessons learned, right? So we don't want to wait until the very end to say, okay, there is a minimum percentage of households or populated areas that are still in a difficult situation. They need to catch up and quickly deliver. So from your point of view, because the Netherlands has very urbanized areas, but there is also strong, rural side of the Netherlands with plenty of interesting applications, by the way, and a lively economy. So what is your view from that point of view?
Yeah, no, that's the coax of the hybrid fiber coax networks, which cable companies use, is in our case 97% consisting of cable. So it's only the last part that is coax. So it is predominantly fiber. And then the question is, do you need to upgrade that last part to fiber as well? Well, you mentioned DOCSIS 3.1, which already delivers gigabit speeds. The next step will be DOCSIS 4.0, which will deliver up to 10 gigabit speeds. By just introducing, well, let's say some software, which is much cheaper than digging up the ground and laying fiber into the homes, because that's the most expensive part. So no, we don't see the need to upgrade to fiber. We don't see that fiber is the last or the ultimate technology. It is one that can compete very well with HFC, but the other way around as well. HFC can very well compete with fiber and is already present in the Netherlands at least. There are cable companies who follow a different route, but that is depending on the country, on the circumstances in that country. For us, it's currently the way we foresee it is that we just upgrade to the next cable technologies and stay ahead of fiber for quite some time. And what happens after that remains to be seen.
Maybe can I still add to the question, because and sorry to insist so much, but of course for us it's a really relevant discussion also in the wider context of policy making. So the question is how you see this in terms of the fact that cable is of course also using shared capacity. So the question is, what can it deliver? And then one thing that is particularly interesting is that we certainly see that the download speeds are fine. But what does it mean in upload speeds? And there we think that we're moving to a society where we will not only have plenty of these kinds of conversations with many people listening over the internet, but even metaverse, augmented reality, virtual reality. So will you be able to manage still with cable, or will you have to adjust for certain pockets of areas where you still have to surrender to fiber or not?
Yeah, that's a nice way of phrasing it. Now, it's until now, and that's what we still see in the data, is that the upload is much lower than download, or download is much higher than upload. And the amount of data that you need to watch videos or watch Netflix, etc., is much higher than what you're uploading, unless you're a movie star yourself and you're constantly making movies and sending it out.
We don't exclude anything here.
No, and the metaverse will probably change it a bit, but still the expectation is that you need to download much more than you're going to upload. So that there is a disbalance between up and download is reasonable, and whether that needs to come closer to each other, that might be expected. But that is also what the new technologies enable for, especially cable. Copper, probably not. That's why they're all upgrading to fiber. But for cable, that will also be manageable, especially for the coming, well, maybe even 10, 15 years. And then there will be new technologies. And since they're not there yet, it's hard to predict what they will be able of doing. But then it will be even better, is a guess that everybody can make.
Okay, thank you. So I think now we need to also move to the space.
Absolutely, absolutely. Sorry. I mean, Artie, it's the last is really the not least, but doesn't mean that it's less important, because here really, again, one message we are getting from you that all technologies, all approaches are important to support our gigabit connectivity goals, provided that, of course, ensure minimum type of performance, right? And Artie, what you say, I mean, you seem to be quite confident, actually, when you show this layered picture of the different type of satellite systems, that indeed satellite can indeed guarantee a certain minimum level of performances. Now, when you speak about those performances, are you speaking about overall the aggregated type of bandwidth that a satellite system is capable to deliver, or we are speaking about really the ultimate performance that me as a consumer I'm benefiting from? And secondly, is what is the level of reliability of that performances in satellite systems, considering that they, for the good or for the bad, they share the similar characteristics of many other type of systems where you have a shared medium that needs to be shared with potentially thousands or 100,000 millions of users. So for us, peak performances are quite important, in other words, and how satellite technology can cope with the somehow stability or reliability of the declared performances.
Sure. There's different layers, of course, in my presentation, but you're asking specifically about satellite broadband. If I take the example of the Eutelsat Connect satellite, which has overall, I think it's 500 gigabit per second just for Europe. So you have 3 different offers that they have for individuals here. We're not talking about backhaul for telcos. We're talking about consumer broadband. So you as a rural citizen, what could you expect? You can contract for 30 megabit per second, 50 megabit per second, 100 megabit per second. These are the theoretical maximum data speeds, which are advertised and normally available. With the 100 megabit per second, if you went for that, the normally available is closer to 75. It's important to remember that contention on satellite systems is never as intense as it is on terrestrial, because even if you talk about a few million, it's a few million across Europe and across different satellites or across different transponders. So what is advertised and what your real experience is generally a much closer match on a satellite broadband connection than it is on a terrestrial broadband connection, where you necessarily have a lot more consumers connected. What was your other question? Sorry.
No, I think you covered. I think it was more really at the level of reliability or stability of the declared performances for the ultimate customers.
Yeah.
Can I?
Yes, please.
I would also still have a question to you, Artie. So I think it's fascinating what you paint in terms of the speeds that can already be realized by satellites and how satellites are a real alternative. The question is also to make that available as widespread as we would like in Europe. What, in your view, is still necessary in terms of investments and time? And then also the ultimate question is, I guess it would mean many more satellites to be put in the orbit. And isn't there a sustainability issue?
So let's take sustainability separately, but in terms of what needs to be done, I think we have a problem in bridging the gap between supply and demand. The demand we know is there in the rural areas, but the lack of knowledge within member states of how do we access satellite broadband, how do we use it, how do we deploy it, how do we make voucher schemes work, what is eligible, what is not eligible. This was very clear when all attention was on the 2013 objective of connectivity for all with Neelie Kroes. At that point, we were asked to put the website in place, broadbandforall.eu. The website still is there. So at that point, it became very clear, and we also gave guidance to member states on how to put voucher schemes in place. But meanwhile, because the narrative at political level has moved on so fast that all of the attention has gone away from that. Granted, also, we've made a lot of progress, and the digital divide now is much smaller than what it was back in 2009. But still, there are some millions in Europe that need to be connected. Satellite is the only way. But how can we support Connect in making policy for a tiny percentage of European citizens when, in fact, most of your attention and investment is on the other is on a very different objective, right? That's something that we should figure out together. Is there enough capacity to connect them all? Sure, there is. I mean, during the pandemic, the operators providing satellite broadband ran out. They ran out of capacity. But since then, so much more has come into play, whether it's the NGSO systems, whether it's the VHTS, which is now emerged in Europe, so the capacity has come up. And as soon as a new satellite system goes up, all of a sudden you have a huge amount of capacity which is available. And so this fluctuation between demand exceeding supply and all of a sudden supply exceeding demand, the cycle goes the other way again. So there's no issue on supply and on capacity. Therefore, no, it's not a question of waiting for a lot more new satellites to go up, but that doesn't mean that space sustainability, if we come to that topic, isn't an issue. It's an absolutely important issue, and we count on, DEFIS rather than Connect, to do more on the space traffic management side. We, from the operator's perspective, GSOA is global, so we have NGSO providers, we have traditional GEO providers and MEO providers. They don't all share the same view on how to approach the topic, but they all are absolutely serious about it needs to be tackled, because at the end of the day, private operators can care about preserving their investments, and the only assets that they have really, I mean, apart from the ground segment, is the space segment. That's the riskiest, the most expensive. So it's there. And I shared in the chat a link to our paper. GSOA has given very clear recommendations to governments on what needs to be done to tackle this topic. And the only last thing I would say is that space is not European. Space is global. Space sustainability is not a European concern, it's a global concern. So while we have a European space traffic management initiative, it won't ever achieve its objective if it remains only European. There has to be partnerships. That's something which the EU is extremely good at. The Commission is very good at enhancing its partnerships, especially on space with other sectors and other countries. And so we encourage you to do more of that.
Thank you, very clear. And I think we should always take up the invitation to cooperate more. So certainly.
Thank you.
Absolutely. So, Artie, I want to ask you a question. I mean, in the past 2-3 years, we have seen some evolution in the market, the satellite market, right? So we have seen the case of OneWeb, which has evolved and it's probably continue to evolve. Starlink coming now to reality, and there are still some discussions on possible mergers, acquisitions, etc., etc. So from GSOA, probably this is a question you might not be able to answer. Let's say you might want to express your own personal view on that rather than one of GSOA. But how do you see really the satellite market evolving in the coming, let's say, 3 to 5 years, and perhaps beyond? And secondly, in this vision, how do you see the European internet satellite providers? Which kind of role they could play in that broader game?
Well, you don't ask hard questions, do you? How do we see it evolving? I think that the innovation, the pace of innovation that we are seeing and that we have seen in the last couple of years is going to continue. I am struck by the number of new types of services and new market segments that the operators are connecting and enabling. Things that we don't even know. All of a sudden, we're monitoring aviation and supporting the reduction of CO2 levels. There are IoT applications in all kinds of fields that I, at association level, was not aware of. So certainly the pace of innovation and connectivity for new services is going to maintain, especially also, just like you see with terrestrial, you always say that we don't know what kind of services are going to be demanded in the future. Users may not know today what they may need or what they may actually be asking for 5 years down the road. And I think the same is going to be true as we see all of these new satellite systems emerging. I think that we're not necessarily conscious of the scope of what they could actually achieve. With the lower latency that's coming with these services, but also the vast increase in capacity of the systems. So what can you do with all of that? Here, I think you're going to see SMEs emerging with new ideas as well. So the future is bright from that perspective. The risk, of course, the collision risk in space with all of these new systems is also very, very real. So that's, does the association have a view on that? No, just that we need to act. We need to do something. We need to probably regulate to some degree. It's ultimately, it's in the hands of national governments how they want to treat that. Just like they have decided that, okay, a digital divide in our country, even if it's just 1% or 2%, is no longer acceptable. Therefore, we translate that into a license obligation. So bringing a policy down into a very pragmatic interpretation, I think the same thing probably has to happen to maintain sustainability as well.
Thank you, Arti. And Rita reminds me that this is one of those questions that, to be politically correct, you have to ask to the others as well. So, Bruce, how do you see then? That's a state question really reflected on the submarine cable market, let's say. What do you think about its possible evolution and the role of European players?
Well, I think I mean, there's, as we all know, exponential growth, and the suppliers are attempting to increase capacity to meet that demand. At this point, it's not just supply chains and so on. It's actually availability of cable ships to some extent is limiting installation and so on. But at least my interpretation, having gone to industry conferences and so on, Singapore just a couple of weeks ago, the submarine cable community is relatively upbeat and sees no major impediments in the future. The one aspect, this is perhaps more in the future, 10 years maybe, but they're still looking for the next technical revolution, basically, in how to increase bandwidth on a single fiber. They're at a Shannon limit given current technology. They're looking at multi-core fibers and hollow core fibers, but it's kind of at this point, it's an arithmetic growth curve. And so there's, something has to change in the next 5 or 10 years. And it's not clear what that is at the moment. But I think, and there's recognition that there needs to be more diverse paths, geopolitically diverse and geophysically diverse, and that's happening. I mean, we're looking at cables across the South Pacific, Chile to Asia. Darwin is sort of supposedly going to be a new hub, and there are other drivers, that link Australia to Africa directly. and so on. So my take of again attending these conferences and talking to my colleagues in that field is that you know, the outlook is good to meet demand in the future, but it's a continuing process. And I think also the companies are absolutely looking toward the CEF funding to help implement the digital gateway concepts and so on into Europe and really providing connectivity to all of Europe across the globe.
Bruce, if I may ask a question.
Yes.
Europe was on the forefront of the internet together with America, because we had these undersea cables connecting Europe with America. Now that you see that a lot of cables go directly from Australia to Africa, as you just said, is there a risk that Europe is getting less important, so to say, in the whole infrastructure? And does the European Commission need to do something about that? Or can they play a role?
Well, I think my understanding, they absolutely do recognize the need to have better international connectivity and along diverse routes and observing sovereignty issues and so on. And that is explicitly, you know, one of the purposes for this, the CEF funding is my understanding. So I think Europe is definitely on the right track. Yes.
Okay. Let's hope.
Things.
Yes.
However, of course, the CEF fund is certainly, it would be fantastic if only with CEF we could fulfill all needs that are coming for the next years ahead. The point is that we want to use the CEF also as a kind of mechanism to catalyze investments from the private sector, and also as well as also when we connect the other regions worldwide, also from the other side of the cable, let's say. That's very important. Anyhow, thank you, Bruce, for reminding us about the CEF, definitely. Rita, I wanted to say something.
Maybe thank you also for the question, Bram, but I would like to also ask this question about how do you see the sector evolving to you? And in this context, I wanted to also point to the fact that Commissioner Breton, I think, rightly put the metaverse as the next horizon, or Web 03. Now, I think in the telecom sector, we are living in a vastly changing world with cloudification of network slicing, network sharing, with the big tech players offering a number of services that used to be provided by telcos. So the question is, in this context, how do you see also business models and funding models evolve in the coming, let's say, digital decade?
To all.
Well, but also to Bram, for the land aspect.
Yes, exactly.
Thank you. Sorry.
I think Bram better.
Well, again, that's not an easy question. Funding for new networks was quite easy the last few years because the interest rates were so low, and I think that's one of the reasons why you saw this boom of new infrastructure coming into Europe. That will change. Well, that is changing already a bit, and that will be a challenge for the Commission, but also for the private companies to fund the rollout of new high capacity networks. But we do need them because we are going towards a fully digital society. So that's a question not easily solved, and also for me not easy to give an answer to.
Okay, I can see. I mean, of course, no one of us has a crystal ball, so it's difficult to say. But I think what seems to be clear is that we live in an area of change, no? Changing technology, changing demands, changing business structures. So indeed. So I don't know. I think, Frank, we should slowly perhaps move to the end because
Yes,
it was
sort of wrap it up.
quite an intense session.
Yes, indeed. Actually, Rita, I wanted to ask a question to the table, particularly to you, because there was someone here, again, the usual anonymous, saying, what is different compared to 10 years ago? What is evolved with the connectivity? Well, I would say, I mean, to say the least, we have different targets, right? Set.
Yeah.
But I just wanted to, but Rita, please feel free to complement here. It's not just an exercise we do every 10 years or every 5 years. We do a study, we say, yes, there is an increasing demand for connectivity. We need to set new ambitious targets there. And then we start the race against those targets, etc. I think we need to really be convinced that this time is different. The DDPP that Rita mentioned at the beginning will make a difference. Actually, I must say that the digital agenda was already designed to be as a kind of overall project with target, etc. But we didn't have the mechanisms there thoroughly discussed with the member states and agreed upon, by which all collectively we work together to achieve these targets. So that is where we have a first difference. But the other difference is that really, I mean, I must say we see a lot of more enthusiasm all around from the different sides to say, let's work all together to not only develop the necessary infrastructures and deploying these infrastructures, also to allow their take up. And also from today, what I learned is that really we need to focus also on the integration of the multiple solutions. We see the example of 5G with the satellite. Okay, it might not be really already today, but it will, I mean, people are working around that to make it happen. So in other words, I think, Rita, I don't know if you have to add other things on that. I mean, what is different?
I think you were pretty complete there. So to me, indeed, what is different is, for instance, the fact that we in the telecom sector, we have more competitive markets. As Bram was also signaling, we were able to deregulate many markets. So there is also this vast increase in data being handled. There's the arrival of new players. There's the increase of much choice for consumers. I mean, I am still one of the old-fashioned people who watch regular television, but nobody in my environment seems to still do that. So you have so many changes on the market. And in that sense, I think, I mean, certainly now that we have also seen that we need to act in Europe as a whole to tackle these global changes to a certain extent, it's very good that we are now defining this program to work together and also to engage in projects in which the member states will work together to realize these targets in a common way. Now, I don't know, shall we say, any last comments by the three speakers? One, if you can make one observation in the context of this, let's say, future-oriented end of our discussion. Let's move first maybe to Bruce. Because,
yeah, I'd just like to say
very much your overtime. Yeah.
All of these land, sea, and air, they all have complementary features, and we need to make sure that we acknowledge the pros and cons of each one, but understand that to achieve true resiliency, you know, in the face of natural disasters or outages or whatever, you know, we need aspects of all three, and none of them really stand alone by themselves, and we need them all together.
Thank you very much. That's a wonderful end from your side. So Artie and then Bram.
Yeah, I would actually echo that. I think it's a mistake to really take a binary approach and just consider technologies as alternatives. We see, just like countries are diverse, the answers are also diverse depending on the challenges. And very often, especially as we're moving towards a converged world, a converged networks, where there's a lot of network integration, it's going to be hard to see standalone targets and evaluations of technologies by themselves.
Thank you very much. And so then, Bram, thanks.
Very hard to disagree with the previous two speakers. So that should could lead to certain optimism about the future of Europe and all the interconnected networks and the way we will be able to digitally connect with each other. The future is promising.
That is a wonderful end of this session. So maybe,
just a few
yeah.
words. I mean, let me first of all say a big thank to all of you, to Bram, to Bruce, to Arti, Rita, and the organizer. Just want to take 1 minute to say, indeed, we have all instruments. The DPP that Rita mentioned about. Concretely, we have also the CEF that has also been mentioned there to accelerate the deployment of 5G and any other type of technology we can imagine. The RRF, I think this is a quite challenge for some member states to implement their plans, but in some cases their plans are very ambitious and supported by the Commission, so courage. And last but not least, we are also working on facilitating somehow investments in gigabit network with the new broadband guidelines for broadband state aid, as we are working together with our colleagues in the DG competition. So I cannot say more at this stage, but certainly those will be in a direction that will support 100% our connectivity goals for 2030. So with this, Rita, I would say many, many thanks again for being with us and sharing your knowledge. I think we all learned a lot about this session. And of course, if there are still other questions to be answered, we can definitely do that offline. And I understand that this session will be recorded for reference for all the colleagues that might not have been able to join us today. Thank you again.
Thank you very much. And thank you to the whole audience.
Thank you very much.
Thank you.
Thank you again for the insights. And we hope to see you tomorrow as well on the sessions on microchips and edge data processing. Thank you, everyone.
Very good. Thank you.
Thanks,
Bye-bye.
Franco.
Bye-bye.